Okay, so at this function, we relabel it, right? Y interval 0 to 4, we double. All the y values become 0, 8. And then we add the 3, relabel the y interval 0, 8. By adding 3 to every value, we get this. We relabel the x interval from -2 to 2 by adding 1 to every x value, because we've got the x minus 1, we've got to add 1. We've talked about why. And what we end up with is a graph that looks like this. So here's our original interval. Okay, there's our new y interval. Then we have -3 here, -1 here. And this is going to be the new x interval. So interval 0, 4 becomes the interval 3, 11. The interval here becomes -1, 3. So that's going to be our interval. And the way it works out then is that our y values will end up here and down here and here. And here. And here. Where this is 5. In our graph, looks like this. Okay? So that's the way it works out. Now, there's a way to tell how to do this graph without having to do all the relabeling. And once you're able to do the relabeling, but we can cut past that. I want you to be able to do the relabeling because it's going to give you a deeper understanding of this function. Okay? We can expand this. Now, all I've done so far is I'm squaring x minus 1, not by some superstition, not by a formula you memorize and might get wrong, but by using one simple law, distributive law. So x minus 1 squared, first of all, means x minus 1 times x minus 1. So we write this as x minus 1 times x minus 1. Okay? And then we use the distributive law. This is x times x minus 1 minus 1 times x minus 1. So we write it out that way. X times x minus 1 here, and minus 1 times x minus 1 here. Okay? We don't do this and this and this and this. We don't make a table. Although if you do, well, whatever points it's worth doing it right, you're not going to get, but it's not going to be a heavy penalty right now. Okay? But I've done it enough times that you should pick it up, because that's what's really going on. The other thing is just a way of seeing what it is. Okay. Anyhow, x times x minus 1 is x squared, and x times minus 1 is x. Minus 1 times x is minus x. Minus 1 times minus 1 is plus 1 plus 3. So y equals 2 times x squared minus 2x plus 1 plus 3. We use the distributive law again. We get y equals 2x squared minus 4x plus 2 plus 3. And we get then y equals 2x squared minus 4x plus 5. Okay? So anytime you have a quadratic function, it could be written like this. It could be written like this. This is called the vertex form or the standard form. This is called the general form. General form is convenient because you can use a quadratic form, and I'm going to show you how to do that to figure out what goes on with this graph. Okay? Vertex form is convenient because it basically tells you how to relabel or transform the graph. This doesn't tell you how to transform the graph. This does. Okay, so has zeros here, right? How to get that? Quadratic formula. Okay? Now you're gonna want to know the quadratic formula when you take the test. Very important. So don't come to the test without the quadratic formula. It's like bringing a knife to a gunfight. Okay? On the test, you probably won't have to use it more than once or twice, but I guarantee you, you're going to have to use it. Okay? And if you don't know the formula, you just can't solve the problem. You lose some credit. So you got to know the quadratic formula. Okay? It's no surprise, as I said before, that people come into this course not knowing the quadratic formula. But you've seen it, you've used it, people are using it fine in their homework. Okay? You just got to know it. I'm not going to give it to you. Okay. Okay, well, we've worked this out. That's going to be -4. Let's see if I can do the arithmetic right. That's -80, and this is +16. So it looks like this is going to be -64.
That's
Over
actually
2.
4. No, it's
Huh?
4 because it's over 2a, right? 2a is the bottom, right?
Yeah, you're right. It's 2 times 2. See, I told you. Watch me. Okay? Because that's going to be real important. Yeah, leave that off. Okay? Well, that's this, which of course is 4/4. And I can simplify this. This is square root of 64 times the square root of -1. Right? Square root of -64 is the square root of 64 times the square root of -1. Okay? And the square root of -1 is a number we call I, imaginary number, square root of -1, right? Okay? So it's 1 plus or minus 2i. I'm not going to be too worried about the I thing on your test. On your test, really all you got to know is, well, square root of negative 64 is not a real number because you can't square anything and get a negative. Okay? But I'm also want to introduce the I for the reason you'll see in a minute. At this point, you could say there's no real solution. Okay? Now, is there any real solution to f of x equals 0 for this function? Well, is there a solution to f of x equals 6? F of x equals 6 has solutions. And if you've done the homework and stuff, and people seem to be doing kind of okay with this, you can say, well, f of x equals 6, you got to resolve here and resolve here. There are two x values to make f of x equal to 6, right?
That's not right.
What isn't right?
Well, for one, negative 4 squared is 16. So the answer would be negative 24 instead of...
You know, I multiplied that by 4 twice. I told you to watch me. Okay, well, let's fix that. So 16 minus 24 is 4, not 64. So just multiply that, so 4, 4, and then it's going to be 2i. Okay. I got carried away multiplying by 4. I got 20, then I multiplied by 4. Okay? So don't do like I do, do it right. Okay, so here is 4, and the square root of 4 is 2. And 2 over 4 is 1/2. Okay?
It's
So
negative 24, not negative 4. Negative 24.
no, it isn't. Wait a minute. That's 40.
Yes, that's 40. Minus 16 is 24. So it's negative 24. I'm so sorry. I just want to make sure I get it right.
Okay, it's negative 24. No, you're doing exactly what you should do. Okay, now there's another step there. You divide 24 by 4, you get, I'll do it here. You got 4 over 4 plus or minus the square root of 4 times the square root of 6 times the square root of negative 1 over 4. Okay? And now, I get to change things again. I get 2 times the square root of 6. And that's that. I've got to rewrite it. And I'll note that I is the square root of negative 1. Okay? Now, none of that is particularly important for what we're doing with this function, but we do want to be able to simplify this correctly. So don't let that distract you. The point is, we got this function that we got by expanding this, which we graphed here, although I didn't go through the steps, by relabeling. Okay? So, as I was saying now, this is the solution to the equation this has zeros at the solutions of the equation 2x squared minus 4x plus 5 equals 0. And you solve that by plugging the numbers into the quadratic equation and then doing your arithmetic right. It helps if you realize that 4 times 2 times 5 is 40, not 20, and not 80. Okay? So, in any case, what you come out with here is you got no real zeros. Now, what I'm illustrating over here is, okay, you got this graph, solutions of 2x squared minus 4x minus 5 equals 6 can be found approximately by the graph by finding the points on the graph where x equals 6, right? Okay? And those points are here and here. Now, halfway between these two solutions is 1, which is where the vertex is. One, 3, 1, 0. Okay? Vertex is at 1, 3. And you have this axis of symmetry. Why do I call that an axis of symmetry? It's all terminology you should have seen, but let's make sure we've got it. Okay? This might have been a while. We have this axis of symmetry. What's an axis of symmetry? Well, basically cuts the graph into two halves, one of which is a mirror image of the other. Okay? So we've got this half, and if we flip it over to get the mirror image, we've got this half. Okay? And this 0 is as far on one side here of the axis of symmetry as this is on the other. That doesn't look that way because the graph is a little lopsided. Okay? But the axis of symmetry is halfway between, and the vertex lies on the axis of symmetry. Okay? If this equation had been equal to 6 instead of 0, I would have found the coordinates of these 2 points, right? You know, and I have, if I subtract 6 from both sides, I have a -1 here, right? And then I would have gotten a solution because this thing here would have been -4 times 2 times -1. And that would be 8, add the 4, and we get a plus 24. Okay? And I'd have gotten 2 solutions. Now, the big point is that these 2 solutions are on either side of the number that we're going to get here, which is 1. Okay? Because it says 1 plus this, 1 minus this. Okay? If it had been equal to 6, I'd have had 2 square root of 6 and there wouldn't have been any I on it and there'd have been a number here, right? Now, halfway between 1 plus a number and 1 minus that number is what? What's halfway between 1 plus 17 and 1 minus 17? 1. What's halfway between 1 plus 87 square root of pi and 1 minus 87 square root of pi? 1. What's halfway between 1 plus 2 square root of 6 over 4i? And actually that simplifies, you get a 1/2 there. But anyhow, what's halfway between 1 plus this thing and 1 minus this thing? 1. Okay? In other words, the axis of symmetry is always halfway between the 2 solutions, even if they're complex with imaginary numbers, right? Okay? Now, that's really important. So, I'm going to put an end to this video, but then I'm going to go on and show you exactly why that's important.